guys crack on.
Hi, everyone. Thanks, Flutter London, for having me, and Cogeneration for making this happen. I'm a lead mobile architect at IAM. It's like a photo sharing company, so you can upload picture and sell your photos there. Get EPUB from mobile. And today I'd like to talk about this library I wrote, Voyager. And I'm going to start with sample app, so we're going to describe requirements for it, and doing that, I'll walk you through basic API of the library. So we're going to start with a very boring screen, add some title, put some hello world message, like anywhere. A button with a plus icon, and it should take you to other screen. That screen is covered in, by different ticket. It should just display a title of the icon and then like big plus in the middle. And now if we take these two tickets and put them together, we get ourselves like high-level requirements for our app. And I put them as a bullet list on purpose, because you can turn it very easily to something that's understandable to computers, which is YAML, and it's still readable to humans. And this is where Voyager kicks in. At the very top, this file is organized. You have paths, which are destinations for your screens. And underneath, you describe what these screens are made of. And to do this description, on the left side, you provide plugin nodes. On the right side, what's like the value of that configuration. Tiny detail, you also get parameter interpolation within YAML, meaning you can get any argument from path and put it within config. And in this presentation, I'm going to change this. I'm going to reuse these terms as synonyms, because in context in Voyager, they practically mean the same. OK, let's talk about how this thing is organized, about the architecture of Voyager. A central piece is a router, and any router needs a map. And that map, in our case, is that YAML file. Next, when you want to like navigate to any screen, you give a router a path. When what happens, router resolves part of your navigation map, which have all the description what the screen is made of, and starts putting these values into Voyager map. Also under like the respective field names. And by default, this was a string in YAML. It's going to be a string on Dart side. But sometimes this is not enough. So for icon, we had a text plus. And when we want to have on the right side here is icon instance. So we want to be able to use it later in our widget code. And now let's see how you could write one of these plugins. You start by extending a router object plugin. You specify what type it is, which node it should handle, and override the build object method where you have to provide instance of that icon. And the thing we're getting as an argument dynamic config, in our case is a string, so we can use some helper method that will that will return instance of an icon. Every library has its own boilerplate, and so does Voyager. To set it up for usage, you have to load your map from somewhere. Here I put it in assets folder, but you could as well load it from internet or from JSON file. And then the other important ingredient of using router is our plugins. So we need to specify the widget plugin, which helps to translate the home widget in text on YAML side to actual instance in your Dart code. And we also supply icon plugin we've just implemented. Having our navigation map and plugins, we can instigate a router instance. And here's how you use Voyager within your widget, among your widgets. Essentially, you specify path, a router, and your screen is embedded where you want it. Even better, you can just omit router altogether, but to do that, you should provide your router above Material app. And speaking of Material app, like the minimal integration you can do is start by specifying your ench widget home and supplying router generator. Doing this line helps you easily navigate anywhere within your app using standard Flutter API. Speaking about injection in context of Voyager, what's actually happening whenever you embed Voyager widget is you supply it with a path, and that will resolve a config. From that config, the Voyager instance is created. And this allows to create the home widget internally and then using provider supply the Voyager instance to home widget. And in your home widget code, you essentially get the Voyager from provider and next supply it to all the fields you would need to. Like here, the icon will already be resolved to icon, Flutter icon, not the text. And just like that, we've implemented the ticket number 1. I'll leave ticket number 2 to you guys. Now I'd like to talk more about Cogeneration and how it can help us make all of this even better. A prerequisite to using Cogeneration is supplying type per each path. And this will allow Cogenerator to give meaningful names to values and fields it will create. You start Cogeneration by running this command, and it will start watching anything for changes. And if you're like in a CI environment and you only want to run it once, you can supply additional parameter. So this would happen, and we'll create a configuration file for your Cogenerator. You have to go ahead and edit it. So you have a source where your navigation map is located and target where your generated code will be outputted to. You can also specify a Dart file as a source. That is, you put YAML within triple quotes in your Dart file because this allows faster reloads and assets folder don't get reloaded that quickly. Sorry. And that's what you're getting in return. Strong type, paths and types. And why is it good? It lets you turn something manually typed to something much safer. Triangles are my favorite shape. I lied. I want to talk about testing pyramids, Flutter again. And this is where Voyager excels. Because you might ask what Cogeneration has to do with all of this. So you supply extra line to generate some code to your test code, and this will give you this class. And this class is abstract and has two methods because we have two screens. If you add more screens, paths to your navigation file, it will add more methods here, and it makes you implement scenarios per each screen. To write one of these scenarios, you have also like some pre-generated code, which will help you remind like what argument you need to pass, and provide you with widget tester where you do standard UI assertions. And once you have all your scenario class implemented, you just run it from the test code file. And for the example app that's included with the Voyager library, just by implementing one scenario per one screen, it bumped my code coverage to over 70%. It's all great, but I think the major problem with the YAML file is still a plain text. Means you can have type errors there, and this won't get verified by compiler. To mitigate this problem, I added schema validation. And use write schema for each plugin node. So let's start with an icon, the most iconic example. Sorry. So you specify what's the icon in YAML using, it's a JSON schema, but in the shape of YAML. And then what's the output on Dart side? And code generator doesn't know where the icon is coming from, so you can help it by specifying what's the package for it. And like I said, you have to do it for every other plugin node. And this will give you a feedback that the navigation schema is actually correct or there was some error. And there are also changes to your widget code. So now you can use a generated provider, which still underneath is using provider, but does some smart casting. And you can change this manually typed fields into generated ones. And you know, it's like it's good. How it's done, the Voyager instance is extended and has extra getter methods, and router doesn't know about that by default, so you need to supply generated factory method. Last bit of code generation is like a plugin step. It's a tiny part, but it allows you to save 2 extra lines of code. Namely, this will get generated, and you don't need to do that. And if you liked what you've seen so far, the package is available at pub.dev already for some time. And now I'd like to talk about some more advanced things. Voyager is a widget router for a reason. And if we look back at our example, we might think, oh, maybe it's a good idea that we could reuse this fab button across other screens. So let's do that, and let's assign a path to this widget. And if you don't believe me it's possible, you can actually use deepling. It looks kind of ridiculous, but just proving my point. And what's good about this, it is text. You can send that text over the air, meaning Firebase. So maybe a heart icon would convert better. And you can do this while the app is running. All you need to do is turn this piece of text into router path instance, clear existing router cache, and re-register the path. Next time, this will be resolved to heart icon. Flutter 1.2, I believe, introduced like this argument API, and this is useful for cases when you have, I don't know, some kind of service or something you can't really refer by typing path. And this is also like reflected in Voyager API. You need to wrap your argument with this class. And regardless of what kind of method you use to get to the next screen, navigation or embedding, you can get this argument later by unwrapping the value. This brings me to a little bit more weird concept, which is you can have a shoe, class shoe, and you can imagine there is a path for that shoe. And paths work pretty great with Voyager, so we specify for that path we have a widget. And essentially now we can map a shoe to a widget without having the widget, shoe widget in the middle. This is kind of very specific, so let's make it more generic. You can start mapping any object to any class. And if you can do that, you can also start mapping a list of objects to list views. Using standard Flutter API like list view, you supply number of items, and then using Voyager API, you get the item based on the index, and using runtime type, you create a path for your object and pass that object to the widget. If you're curious about this approach, there's like experimental library add-on to the main library. Feel free to check it out. So I was initially thinking I would run second, but there will be more about blocks coming very shortly. And this plugin is for the library of Felix Angelov. It comes like with this basic counter sample, which has 2 blocks in it. Block is a state management system, so like has events, and there will be more explanation next. And what you can do with Voyager in this space is specify what kind of blocks you want to use. So you can have initial state for them, and what type of blocks you want to have on your screen. And to start using it, you need to build your block plugin. The API is similar to widget plugin, except for it has like this repo. So in context are all the things from the router path. So IDs, arguments, and so on. Config in this case is number 42. Repo is allows you referencing other blocks from that screen. And you need to create an instance of your block. I changed how the counter block from the original example looked, to supply it with, to be able to pass like initial state as an argument, and then that argument is used to provide initial state. On the widget side, you have the block field, which returns you a block repository, which contains all the blocks, and so you can find any block by type. Yeah, and this is available also as an add-on package. And I'm nearing to end, so I'd like to recap. Maybe I was like too fast. YAML lets anyone like to start looking at your app. It's where you're like, it's great for onboarding people. You can see like how your app is organized, what are paths, what are they made of. So newcomers or veterans can quickly grasp understanding of where is what. Also, even like PMs can read those. And yeah, if you treat like this navigation map also as your requirements, they get synced with your code. And by having that, we're integrated into your Git history, so you can track changes across time and space, across time and branches. And that's not something you can do easily with Jira, because once the ticket is implemented, I guess you never look back like 1 month from now. The router is the central part, and it will provide you with navigation and deep links for free. So go ahead and use it. It's great. And finally, all the navigation map is a plain text. So you can send parts of it or entire map over the air. And if you pair it with Firebase, it's super easy to set up A/B tests and like check what's working within your app. And it also doesn't pollute your code. So, I mean, how many of you have some random A/B flags in your code, like left somewhere and never, like, were able to remove it later? So, no more feature flags. Hello, feature maps. Okay. Well, are we dead? I had back. Yeah. So this concludes my slides. Thank you for listening to me. And this is the project on GitHub, so feel free to check it out, leave a star, or make a pull request, create issue. It's me on Twitter. I created like the channel on Flutter community Slack. If you have any questions, I'm here.
Hi. First of all, that's very impressive. That's a really nice project, and I'm amused about the functionality that you provide. My main question is how big the YAML file can get, because you said that you can accept every single widget into the YAML file. So how big it can be?
Like as big as you need it to be.
So maybe in other words, when you lost the readability because of the amount of widgets that you will have within the file?
Around 200 lines. Way of turning YAML back to some more readable format. So we could do like reverse. Like when you have this site where I turn it from points to YAML, you could probably do like offer some tooling to make it more readable later. It's like in time.
Okay, thank you.
Any more questions? Anybody?
Yeah, thanks very much. That was interesting. I've only briefly looked, it's quite a general question, but I've only briefly looked into code generation. But do you just generate like large string blobs for code generation, or do you use sort of the analyzer package to sort of generate some sort of syntax tree and feed that back in? And how easy did you find that to build and to debug? Because obviously if you're generating code, you don't get the sort of highlighted errors and things like that. So could you go through that side of it and how easy you found it to use?
I wrote Cogeneration in Kotlin.
Oh, okay.
Yeah, so it's like, it's been like interesting because it started like a prototype project, and what I found it easy to like use Flutter for fast prototyping the app. I needed like this kind of navigation, but I didn't find like Dart at the time like that easy to write, and I was like more proficient with Kotlin, so I started with that, and like the path generation is pretty straightforward because you just need to parse like the top nodes and then like generate that code. And how it's done, I'm writing a Medium article on it, like to explain more. It's not done yet, but basically it's about like using templates and parsing your input to some like model, and then you just model into your template files. So like first I just wrote like Dart file, which this is how I want it to look like, and then just like figure out how to supply all the things for it.
Is it still in Kotlin, the code generation, or has that been ported to Dart?
It's still in Kotlin, but you can run it from the project. How it's done, there's a script downloading a jar file from Jetpack, and that will just run it. So.
Okay, thank you very much.
Anybody else? Any further questions?
Hi. If I understand the Voyager correctly, what you did is you created a domain-specific language in a YAML file and extracted the most important, attributes from widgets into that YAML file. What problem is that solving?
Well, you can, for instance, get to happy paths quite easily. So what I did, had paths for my project, and then had a to-do widget. And then I had 4 of them, so you get entire flow covered, but it also is to-do, ticket, something, blah, blah. And the other thing is you can reuse logic components like blocks across different screens. So a lot of times you can already get to full screen implementation without writing a single line of code. Or you will see, I still need to add something extra. But it gives you more and encourages you to write some code more abstract that you can reuse across different screens.
Okay, so it's an alternative to creating your own widgets class in essence, plus readability on top. So those two things, it makes it easier to see what's going on. Plus, you don't have to create your own widgets class. You do it in there.
It's more like a configuration file for how your app runs. Yeah.
Okay. If I saw the code correctly, then you still write a widget. It's that the values you have to extract from the YAML file, right? You still have to say icon or text or something, and then you just say, okay, now use that text from the YAML file. Is there a way to verify that these values that you specify in the YAML file are actually being used? Because it seems like you could just still go in and say icon and then provide your own icon instead of using that YAML file. So from the outside, it looks like the icon is, a heart, but you're actually using a plus because somebody went in there and moved the, Voyager icon and put something else in there, right?
Yes, it's a problem, and that's why I provided like the schema validation. So you specify a schema for your YAML, so you can actually verify that if it's like correct or not. But also like it's quite open, so obviously you can say in schema or anything can be written here, and then like you just write anything, and oh, it's not working. Well, yeah, it won't work.
Okay. Thank you.
Anybody else?
What would be like a typical workflow of a team like using this to build an app? Would it be that you start writing the configuration file together, and then is it a case of building a bunch of plugins? And how does that fit in with the code generation?
Good question. I didn't think about that. Usually it's you try to divide tickets per screen and just write that. And so it might be tough initially, like if everyone wants to work on the same plugin that hasn't been written yet. That would be a problem. So first would be like agreeing on like the basics of like what kind of components we can reuse. Like, do we have like some block for all the requests? Do we have, so like figuring like the basic building blocks. And once you have that in place, then it becomes much easier to like add more screens or change things.
Okay, cool, thanks.
Anybody? Okay, all right. Well, thank you very much for coming to England to present for us. And yeah, good luck with the project.
Thank you.
And round of applause.